Okay folks, we have been working with this formula for the volume of a cone. And I think we mentioned it in passing, a cone is really a pyramid with a circle as a base. So it's really a version of the volume of a pyramid, except instead of having the area, it's got pi r squared in there, the area of a circle. So, using it in the straightforward way, out of the box as it were, you want to find the volume, you need to know the radius, you need to know the height. But as with all these formulae, we can adapt it so that if you're told the volume, you can find either the radius or the height. So let's have a look at a question like that. So here we are, we've got a cone here. We know that the volume of that cone is 400. We want to find out what its height is, and the other piece of information is that that is 11. Notice before we go any further that that is the diameter. This is this annoying trick we've been playing on you since we started doing the circle in second year, when if you need the radius we tell you the diameter, and if you need the diameter we tell you the radius. But don't be caught out. The first step is to say, well, the radius of that cone is a half of 11, sorry, which is 5.5 centimetres. So there we are. That's important that we use 5.5 for the radius. And the approach, you'll be unsurprised to know, is to write out the formula, fill in what we know, and then try and get to the value we want. So the formula is 1/3 times pi times the radius squared times the height makes the volume for every cone. So the cone we're looking at, we know 1/3 times 3.14 and so on. I'll use the calculator, times 5.5 squared times the height, don't know what that is, but we'll find out, gives us 400, because 400 is the volume. So all these bits here we can multiply together to tidy things up. Nice to have the fraction buttons on the calculator. 1/3 times pi times 5.5 squared. Multiply all these together. So that first bit of the formula comes out as 31.677, and I'm going to keep that number on the calculator because I'm going to use it later. So 31.6777, and the dots mean I'm too lazy to write the rest of that number down, and it probably goes on forever. But it's safely stored in the calculator. Times the height makes 400. So roughly 3 of these would make 90, so we're probably looking at about 12 for our final answer. And that seems a sensible sort of answer for a cone that's 11 at the bottom. So, to find the height, remember, 31 times the height is 400, roughly. So do 400 divided by 31.677, and this is where that answer button comes in handy in the calculator, because all I'm going to need to type is 400 divided by my previous answer is what? There it is, 12.627. So the height is 12.6271, and obviously we don't need to know it to that accuracy. If looking back at the question, we want it rounded to 3 significant figures, so here we are, 12 point, and that's a 2, so it's just going to stay as 12.6. So the height of that cone would be 12.6 centimetres. There we are. That's to 3 significant figures. So again, just reviewing what we did, it was important that we weren't caught out by the radius diameter thing. We got the formula written out. We filled in what we knew, which was the radius squared and the volume. We multiplied all these bits together to get the 31 times the height makes 400, did the divide, got a nice accurate answer and rounded it off as required. Okay, thank you for listening.